Like I did promise in our last lesson, we will take more examples of trigonometric equations of this format. In case you missed our last lesson, please do not hesitate to check the description below. Now, to solve this equation, we will resolve it in the form of r sine x plus theta. So that if I'm expanding this should be equals to r sine theta cos x plus r sine sine x now cos theta. Now we say we're resolving this in this form. So this is equals to 3 cos x plus 4 sine x. Now, so if this is equals to 3 cos x plus 4 sine x, I can begin to group them by equating each part. This first part, I'll equate it to where I have my cos x. This part also, I'll equate it to where I have my sine x. So that we'll be saying that r sine theta cos x is equals to 3 cos x. Now, I can divide both sides by cos x, divide this side also by cos x. So that r sine theta is equals to 3. Let's call this equation 1. Then we'll be saying also that r sine x cos theta is equals to 4 sine x. We can divide both sides also by sine x. Then we'll be saying that r cos theta is equals to 4. Let's call this equation 2. Now, if you take the square of equation 1, it becomes r squared sine squared theta, which is equals to 3 squared. And if you take the square of equation 2, it becomes r squared cos squared theta, which is equals to 4 squared. Now we can now sum up these two equations so that I'll have r squared sine squared theta plus r squared cos squared theta equals to 3 squared plus 4 squared. So that I have r squared now into sine squared theta plus cos squared theta equals to 3 squared plus 4 squared. Now, obviously, 3 sine squared theta plus cos squared theta is same thing as 1. Then I'm left with r squared is equals to 3 squared plus 4 squared. That's equals to 9 plus 16. Obviously, my r squared is equals to 25, which implies that my r itself is equals to 5. Now, if r is equals to 5, that means here I can replace r with 5. So that I'll have 5 sine x plus theta will not be equals to, obviously, equals to 5. Because 3 cos x plus 4 sine x is equals to 5. That will be equals to 5. So that sine x plus theta is equals to 5 over 5. Sine x plus theta equals to 1. We've gotten that sine x plus theta is equals to 1, so that x plus theta will be equals to the sine inverse of 1. Now the sine inverse of 1, x plus theta from my calculator, is the same thing as 1.570 in radians. It's in radians. We're working in radians. So that x on its own will be the same thing as theta plus 1.570. Now, what is theta? Let's get back into our equations. Remember that r sine theta is equals to 3 and r cos theta is equals to 4 from equation 1 and 2. If I divide both equations by themselves, I'll come to tan theta. So that r sine theta over r cos theta will be equals to 3 over 4. R cancels r here. Then I'll be left with sine theta over cos theta is equals to 0.75. Obviously, this is same thing as saying this is tan theta. So that tan theta will be equal to the tan inverse of 0.75. Now theta equals to 0.643 plus 2 pi in radians. Now, so that if theta is equal to 0.643 plus 2.75, and earlier we have established that x is equal to theta plus 1. Oh, that's a mistake. Yes, theta. When theta moves to the other side, it becomes negative. So this is going to be minus theta and not positive theta. So that x now equals to minus 0.643 minus 2 pi radians plus 1.57. So that x now equals to 0.93 minus 2 pi radians minus 2 pi radians. So here is the value of x. We've also solved this equation. I hope with this you should understand how to work with trigonometric equations. Thank you for staying with us and see you in our next class.